What up? I'm doing well. How are you? All right, let's get the spec pulled up. Oh, that's not what we wanted. We wanted the actual spec. There we go. Bump that over, get that there. Good, good. It's Friday. We've made it. Another week. I am working on implementing RFC-1035, which is the DNS spec, and I'm working on building a resolver. So we're working on being able to parse basically raw binary from a DNS message. And so far we have, so a message comes across the wire kind of in this format, well, in binary, but it has a header as a question. It has a answer authority and additional, and we've so far parsed the header, and we've also written the encoder so we can take a JavaScript object and go back to binary. And yesterday we wrote the decoding of the question so we can go from binary to JavaScript, and this morning we're going to write the other direction where we go from JavaScript to binary. Which is confusing because I should have a question type. Yeah. Oh, I need to do, need to come down here and say export type question. Not of it. 1440p is not available in Poland. That's weird. I wonder why. One of these days I'm gonna figure out how to start streaming both on X and Twitch, so maybe it would have 1440p there. All right. So we got this working yesterday. So this is what a question looks like here. So this would be the equivalent of doing like dig example.com for an A record. So that's what we basically just parsed right there. You can see how that the first byte says the length of the domain. How many bytes is the domain name? You can see its example. So this would be EXAMP or EXAMPLE. And then the TLD is 3. So this would be COM for .com. And the question type, which is an A record. So that's how that works. And when we parse that, that looks like, sorry, I bumped my keyboard this morning. This part here, we make sure that it's within bounds, which is basically 5 bytes to 259 bytes. We create a data view, and then we get the first byte and determine how long the domain name is, right? That first byte tells us how many letters is in the domain name, and then we parse that in a while loop. Yeah. So then to encode it, we will go here and we'll say const name length is going to equal header dot qname dot length, and then we'll need the TLD length, which is going to be header dot. Do we push the? Oh, we break it into an array. Right. So that's actually, right here's the result of what it looks like to parse that structure, that binary, is it comes out into this QName, QType, QClass. This first uint array, these are bytes that spell out example, if you were to turn that into ASCII. And this would be com as the TLD. So to go back and convert it back, we go here. Oh, we can't figure this out easy, can we? Because it could have many subdomains. Oh, right. QName is not a string yet. We haven't converted to strings. We're still in binary. So we can go, how do we get the total length? Const length is going to equal we need to like take the header.qname.reduce. You can probably do this faster in a for loop. So let's say let uint 8 array length, or really we need header, what is it, QName length? Something like this. And then we'll get this will be count of, how do they describe, domain name is represented as a sequence of label where each label is of length octet. Okay. Count of number of length bytes needed. Wait, hold on here. Yeah, I need to const label length is going to equal header dot qname at the index, and then we'll go ahead and add uint8 array plus equals the label length, and then we'll keep doing that. Okay. I guess we have an invariant there. Overruns. So we'll take this, paste that there, and we'll say if label length equals, this should like never happen, header dot I guess we could calculate the offset, right? If we calculate the offset, it would be the index what would it be? Be the index plus the index? Is that the offset? No. No. I'm not even going to include that. So we'll do that, get that there, get that there. That will fix that. Number, label length. Oh, right. Dot length. Really, we can just ignore this because this is never going to happen. And we'll just do set to 0. We know that will never be 0. And so we get the label length. We can grab this. Actually, we have that in the console. So let's go down here and grab you. And go back up here. And we'll use that in the example. Paste that there. E X A M P L E, and then we'll get rid of this UN array. We don't need that there. And this will be com we need to insert 2 length bytes. Let's do an extra. This just helps me visualize it. We'll do this. This will be 7. And then we'll go over here. Whoops. This becomes 3. Okay. Does that make sense? I think that makes sense. So the length yeah, no, I'm doing this right. Dude, this is such a... Binary encoding schemas are so cool. I'm pretty sure this is called run length encoding. Let's find out. Is this run length encoding? No, this is not run length encoding. Ah. All right, so we have the length then, and then we know we need another, this is 2 bytes and 2 more bytes. So we need another 4 bytes. Uint, we can do that up here. Plus 4. 4 is the two uint16 values for Q type and Q class. And then we'll say const new, this will be our buffer, going to equal new uint or new array buffer of length. Let's rename this to buffer length. So this will be buffer length. I think we can be smarter.
Functions describe
When we're iterating over this, we might be able to do this in one loop. Thank you for the follow, Crystal. Chris LeBron. I said Crystal. It's hilarious. I'll be right back, chat. Yo, this song's kind of fire. I was out in my kitchen just jamming. Thank you. Thank you. From the deepest part of my heart. What would we do without you? This stream would be nothing without Kraut. Literally the foundation and the pillar that holds the rest of us up. Unironically. Kraut does run chat. Alright, so this should be the buffer length. I would like to not loop over this thing again, which is the part that... What is a way we could do this? Like we could... Can we do this without a second loop and without any allocations? Hell yeah, Sally.
Functions describe the world.
Do you have any idea what you want to build, Sally? We could store the length, or we could store the size on the header struct. That's probably worth it, right? Oh, that'd be sick. I don't think I've come to the conclusion that effect is not overkill for anything. I build faster, I build more reliable, and I have fun doing it. So I want to use it for everything. If we store the size on here, we can encode much easier. We can encode a lot faster. Let's not do that. Oh yeah, we're using let me see. Let me pull up. We're currently rebuilding all of our registrar services. I can probably show you guys some stuff. We're rebuilding all of our registrar services, APIs, and UX, and it's all with Effect. Outside of the Effect core team, I probably have the strongest team of Effect developers in the world. I have Ethan Nizer. I have Elliot, who came to Vercel from Mark Prompt, who was a prominent member of the Effect community. Reese is skilling up in Effect right now. It's really, really fun working on this team. Where is some stuff I can show here? I'll start with showing some UI. Where is this? Project search by. So we are working on, so today, I mean, where do you work if you don't mind me? I work at Vercel. I don't know if that's a joke or not, but I work at Vercel. So today I lead our domains product. So domains, DNS, certificates. So today this product is like 8 years old. This has been basically the same experience for like 8 years, and it's still like plain JavaScript. So if I come in here and I want to search for like effect cookbook, I get all these prices, right? So we're rebuilding all this right now. Today, this is kind of what it looks like. You get this ugly little modal, you go through this, click confirm, and it would buy. And then to manage your domain, you would come over here and let's just say you come over here and then you can manage registry stuff. You can manage your DNS records. I don't know why this is taking so long to load. Hold on, Justine's calling me. Hello? Nope. Actually, yeah, toothpaste. I need toothpaste.
You're finding toothpaste, right?
Yeah.
Okay. I also need toothpaste.
Okay.
Okay.
Bye.
Bye.
I'm hoping this isn't an incident. Does anyone else have a domain on Vercel that they can go check if this is happening to them? Hold on. Is it this? Okay, it was Dark Reader. Whoo! I just almost panicked. I was like, is there an incident? It's just freaking Dark Reader. I hate Dark Reader, dude. So we build all that. So we're rebuilding. This isn't going to get changed immediately, but the buying experience for domains is. We're working on rewriting that today. And as a sneak peek of what that will potentially look like is kind of like this. And you'll be able to search by, like, it'll give you like AI-based suggestions. So like you'd be able to come in here and be like, domains for a bot directory startup with halt and catch fire vibes. Or you can just search by TLD or domain name, multiple checkout. So we're rebuilding all of that on top of Effect, and we have a bunch of the underlying services already written. So I might be able to show some Effect code that's really cool. Let me go look at my repo quick, because the core service doesn't have any Vercel specific stuff integrated yet, and it's just Effect code, which is fine to show. And it's really cool. We've got some cool patterns. Uh-oh, I want to know. Oh, right. I need to log in with 1Password. Freaking 1Password, dude. I hate Okta with an undying passion. Actually, I could probably pull it to my editor, actually. That'd be easier. Do you use AWS heavily at Vercel? Yeah, we use a lot of AWS stuff. Instant domain search, that is our target to, we're aiming to be faster than instant domain search and have a better experience in instant domain search. That is like one of the North Star goals of this project, Sally. So hopefully Vercel domains can replace that here in a month or two for you. And the one thing that's really annoying about instant domain search is that like it has to redirect you to like partner websites where like we're releasing new pricing when we release the new search by experience, and our prices will be competitive with Pork Bun and Cloudflare, and we'll also have logged out search, which we don't have today. So we're trying to like be as fast as instant domain search, and then just like stay out of your way for buying and configuring domains to like, we basically want to fill the gap that Google domains left, right? Like a no nonsense, just easy place to buy cheap domains, easy, get DNS configured correctly. Like you don't have to host your site on Vercel. Like just throw our name servers there, point it anywhere, and you're good to go. So that's the goal. Obviously, there's many benefits if you decide to host on Vercel, but yep, GoDaddy sucks. I've tried to work with GoDaddy's devs on some things over the past couple months, and they are like an actively like hostile company. No, we have no markup on our domains. We sell at cost, Pepper, and so today we sell at cost. So directly we pass through prices, and we have better pricing arranged with our upstream partner for when we go live with our new search by that will drive the cost down even lower. Sally, if you do switch to using Vercel, like anytime you have feedback, bug reports, feature requests, just DM me, and it will get taken serious. All right, let me see if I can. I want to show you guys some of this effect stuff. For the wicked. So good. I thought I was gonna say let Anders know. Does your job allow using AI for coding? Yeah, I use AI, but I don't use like Cursor or anything like that. I find Cursor to be, I don't know, I don't love the vibe coding experience at the moment. I certainly use it for repetitive tasks or when I have a really well-established pattern and I needed to do something. It's very good at writing property tests with fast check. So I use it for that. I mean, I use AI a lot, but I'm not using it like vibe coding style for work. I don't really vibe code in general at all. API domains registrar. Where is this guy at? Okay, this is the code I can show you. So this is the effect service that's going to power that screenshot I showed you guys. So this guy right here, what we're working on, this code that I have up on screen right now is the effect service that's going to power that. Let me get up. I just lost. Let me move this over, and we're going to put this here, and I want to get. We'll talk about RFC-1035 in a second. Just started using Next.js and React. I'm behind with the times. Oh, you'll catch up plenty fast. So the entry point to this service is this. In effect, you define your API. using a schema, kind of like Zod. They have, if you guys have been watching me, we use schema a lot. This is basically their version of Zod. So we have like this sync TLDs endpoint, which sync TLDs like goes to our upstream registrar partner and syncs prices and like any, if you need to supply extra information at registration time, the amount of years you can register for, stuff like that. So it's like the query params, it takes a registrar, except or error supported TLDs. So you just go through and you define your endpoints like this. It's really nice. So here's an API group, right? It's all nested under /TLDs. So we have sync TLDs, get supported TLDs, get TLD by name, get TLD price. We can say we have auth middleware. And then what that looks like to implement is I have that over here. And let's say we want to get our supported TLDs. So we implement our handler over here. We have like this domains registrar client, and we say TLDs get enabled. OpenSRS is our current upstream registrar partner, and we map to those, and yeah, we get free tracing. It's super nice. You can generate open API specs with one line of code, so you can get Swagger documentation you can host with a basically, you know, where you can just issue REST requests from the browser. One line of code to generate that. What else is cool here? You can type gen a client with one line of code, which is sick. So this creates a client that I can call my endpoints with. So I can take this client right here and use it on the front end on Vercel, and then I have a fully type safe client for making requests back and forth between the service. What else is cool in here? We can do middleware. Yeah, so this is like literally what's going to power search by. You're looking at it. And this is where we build up our server. We set up cores, we pass in our API, we pass in our middleware. We have an RPC layer, which is really cool. So we're using like an RPC endpoint to communicate internally. So this is like behind our, like it's within our private network, and only other microservices can hit this RPC route. Super cool. It's been a really great experience building stuff with Effect. So I'm all in on Effect, and so is my team. So why are we implementing RFC-1035? That was the next question. So 2 reasons. One, I want to get it added to Effect's platform package. So Effect has this thing called its platform package. And this is essentially a bunch of utilities that can be used across platforms. So whether that's Node, the browser, Bun or Deno, or even like Cloudflare workers, all of these interfaces are generic, and then there are implementations for them for each platform. So these are like the interfaces, and then there's like implementations for like platform Node, right? So like a bunch of those have implementations in Bun. So then you can write your code using those interfaces, and then you just provide the implementation at runtime for the platform you're running on. So you can basically write once, run in the browser, run in Bun, run in Deno, run in Node, run in Cloudflare workers, and it just works if you code against the interfaces. So what we're doing is we're making a DNS resolver, right? Which a DNS resolver is just like dig example. If I want to get like the IP address my website is at, right? dylanis.online a, right? Gives me my IPs. We're basically writing a resolver, and the one, I want that in Effect Core anyways. 2, we're implementing RFC 1035. Rather, the easy route would have been wrapping nodes standard library, right? Node has a DNS package, and so does Bun. Bun actually just passes through to nodes, so it's like basically the same thing. Denos is a bit better, but we're writing it from scratch because, for example, one of the problems with the standard library in Node, like resolve txt record, if I do dig Dylan is online, if I do, I wonder if I have this Dylan is online txt. Yeah, okay, so I have a txt record here, which is often used for like domain verification or proving that you own a domain across other services. So this is saying for this subdomain or this DNS zone underscore Vercel.Dylan is .online. This has a TTL of 60 seconds, so 1 minute. DNS records will always have in here. It's a TXT record, and then this is the value. If you use Node's standard library for resolving a TXT record, it's only going to return this. It does not return the whole record. So like I don't get the TTL back. And like for other records, other records have more important information than just this stuff. Like it's picky about what it returns. Like here's just a string array. Like I want the full record. There's also problems with how it does syscalls. It can cause thread starvation when you use resolve under the covers. If you don't do it correctly, you have to be really careful. Basically, Node's DNS is just really problematic across the board. So that's why we are writing it from scratch and doing it ourselves. All right, let me catch up here. What's your opinion about Voyager keyboard? I love my Voyager. What up, MS? The build behind you set things up kind of reminds me of .NET Core. Yeah, it's a really nice... yeah, that code base I just showed, Sally, with the API is closed source. But there's... If you go to like grep.app, you can probably find some good examples of people using Effect open source. Let's see here. You can probably search like at effect/platform and do like HTTP. You can probably find some stuff in here. Yeah. Like really easy caching too. It's just, Effect is so nice. It has everything you need. Like actually for all the Effect services I've written at work, the only third-party package I've installed is Flat, which is a package to literally just flatten JavaScript objects. And I use that to pass into telemetry. This is the only third-party package outside of Effect that I've needed for any of the services I've written. Grep.app is awesome. We like acqui-hired the company and team, and we're actually using a lot of what we learned from porting grep.app to Next.js is what we're using to build search by, which is why we're like one of our North Stars for the new domain search is beating instant domain search, because we learned a ton from this. Like, you know, like I don't even know what to look for here. Like effect/RPC. Like, look how fast that is, right? Like, that's insane. So we're taking a lot of what we learned from this and porting it over to domain search. So super exciting stuff. We'll probably, I'd like, once we get search by published, like I think we're probably going to write an engineering blog post or a couple of them, because there's so much cool stuff we've done. Well, we've done some stuff already, but like the optimizations that we already have are cool and awesome, but we have a bunch that are just like sitting in our back pocket that might not make it for GA, but like we've got so much cool shit to make it even faster. Like one idea we have is you can, if you have an ICANN account, you can sync with the root DNS zones once a night and have like you. What that means is basically you can get a list for every TLD, so .com, .online, .dev, .ai. You can sync basically a list of every registered domain for that TLD via SFTP every night. So we want to do a thing where we sync that data every night and load it into a Bloom filter. And then we can use that Bloom filter for instant lookup if a domain is available. So that means no network calls to third parties. It's just like you hit Vercel, you hit whatever the closest edge to you or server location is to you. You hit the Bloom filter, and you can instantly see if basically any domain is available in O1. It's gonna be so sick. I can't wait. And we have like another optimization where we're gonna do like we have, rather than like hitting our upstream registrar partner, so like the traditional way to check if a domain is available would be like you type in example.com, that hits our server goes and hits our upstream registrar and says, hey, is this domain available? That comes back, goes back to you. We can basically do a strategy where we race 2 network requests. So the first network request is query upstream registrar partner for availability. And then the second one is DNS SOA record query. And a SOA record is service of authority. So if we do that for like my domain, right? Let's say we dig dylanis.online and we do SOA. Whoops, SOA. We'll get this record back and you can see like this information. And if this comes back, right? If there is an answer here, that means that the domain is not available, right? So if we get a hit, that can tell us immediately that the domain's not available. Let's see if I can like get, like, I'm sure like this is probably not a registered domain, right? We don't get an answer here. So this basically tells us this, we can't trust for certain in the absence of a filled out record. So we have to fall through, but we can also like cache start of authority. Oh my God, a use case for Bloom filters in prod. I know. When I realized that that would work, Sally, I was like, oh my God, it's the day. I can use Bloom filters. It's happening. Let me go calm down the dogs here.
Functions describe
Why
the
do you,
world.
hey, you, no. Why do you think this is okay? Calm down. Relax. Sit. Down. Relax. Calm yourself. You need to get better at calming yourself down. Relax. No. Calm. Baxter. Relax. Good boy. Good. No barks. You don't want to come in here. I'm shutting the door. How do you think this is okay behavior? All right, so where we leave off, we are putting back together this, we're going from a JavaScript object to binary, and we have the total length of the buffer. It would be nice to not have to loop over again, but I also don't want to allocate memory again. Can we do this with one loop? Oh my god. These dogs are driving me crazy. Sorry for the dogs barking, chat. I have people going in and out of my house. My mom, oh my goodness. All right, hold on. Hopefully, I put on Netflix for them. Hopefully that like sound covers any noises they're hearing. So both Justine and my mom left, and my mom has 2 dogs, and she's walking them. So Bodhi is jealous and upset that he didn't go. And then when Justine's not there, Winnie and Baxter bark at any freaking noise they hear. Oh, dogs, yo. I guess we can do this again and it's fine. Well, let's create our data view. Well, let's just do it the easy way, and then we'll see if we can come up with a better way to do this. And so we'll do we'll loop over, basically do this same loop here again, but here instead in the loop we're going to say data view dot set uint8, and the byte offset will be the index, and then we'll set basically this, the label length, and then we set we'll do data view dot no, we don't do data view here. We want to do buffer dot Oh, I guess we would do a nested for loop then. So let's rename this. This is like offset. Something like that. I don't know if that's necessarily true, but let's say let index. They're watching Gabriel Iglesias, I think I put on. It's the first comedian that popped up. I think we do this, and then we do data view dot set uint8, and this will be offset plus index will be this. This will be label. And this should be a uint8 array or undefined. Let's slash to do fix this. And then we will do const label. This is like label offset actually. We get the byte const label data view equals new data view label.buffer. Oh my god. You guys are ridiculous. And we'll say const byte is label data view dot get uint8 at our label offset. And then we place the byte. We'll just fix that in a minute. Should do remove non-null. Remove non-null assertion. All right, so for every label, we set the, so what we're doing is we're building up this array right here. Given this array, or yeah, this array of arrays, we're mapping to this array of arrays. So we get 7, right? We get the length, this would be 7 for example.com. We set at 0, 7. We move forward. Well, really, this will become a flattened array, right? Like this just becomes that. And this is technically where we're getting to. This is the thing we're building right here. So we set 7 right here, and then we're iterating over this array. That's this for loop right here. And we're going byte by byte and grabbing that and setting it into our outer buffer. Yeah, I think that's right. And then we would do data view dot set uint 16, and the byte offset would be buffer length -4, and the value we would put there will be header dot q type. And then the last one would be, instead of -4, it's -2. And this would be Q class, I think. And I think that is correct. And then we would do new uint 8 array, and that would get our array buffer. Hey, do you have any advice transitioning to private sector? I've been working for the government for a while now, and the stuff we use is old and changes to our products is super slow. We use .NET for backend and some front end and Angular, if that helps with your advice. I actually do have some advice here. I spent 4.5 years, 4.5 years, 4 years, 3 years, 3.5 years, 4 years, doing defense contracting for basically all the 3-letter agencies. I lived up in the DC metro area for a while. And I will say there is a ton of stigma in government contracting, or at least there was when I was there. This is back in like 2016 to 2015 to 2018 timeframe. There's a ton of stigma that you'll lose work-life balance, you'll lose job security. Like, basically there's a stigma inside government contracting that private sector is so much worse. And that's just not true. And there's also the like internal thing that, like, because of what you're saying, you feel like you're not as good or ready or as capable as devs in private sector. And that's also just blatantly not true. My best advice is just apply for jobs, keep trying, like, for better or for worse, build stuff outside of work, build up a portfolio. And like the portfolio stuff you build, like, don't build stuff to impress people, build stuff you want to work on and build, because that's going to shine through way better. They need to tell themselves that because of how much private sector earns in comparison. That's not always true in defense contracting, Anders. Like, I could probably be making at least the same, maybe more, defense contracting, at least at the firm I was at. But I wouldn't have equity, right? I wouldn't have, like, the options and the RSUs and the opportunity to, like, make meaningful money in that way. I mean, I guess if you work at like Palantir or something, that might not be true, but I would never want to work at a large defense contractor. Working at a tiny defense contractor was pretty awesome, but I would never want to be at like General Dynamics or Booz Allen Hamilton or any of those places. Yeah, no problem, Pepper. If you ever want more advice, feel free to like DM me on Twitter, or just come back to chat. Happy to talk about that stuff. All right, chat, it's time for our meditation. Of course I saw the beef. How could you not? It's true. It's true, Cowboy. I like retyping this rather than copy and pasting because I feel like it just helps me learn what's going on here and think about what's happening. So that's why I didn't just copy and paste this stuff. Linus Tech Tips. Get your own screwdriver now. I'm not going to lie, when the tariffs popped up, I bought their tech sack and precision screwdriver. What is this? I don't, actually. I know Crabrave from watching the Coppinger. He's not chronically online. What the fuck? I don't watch. I assume I don't watch Linus Tech Tips. To be honest. So Linus Tech Support uses CrabWave to test every audio device because no DMCA strikes. Ah, this is starting to make more sense. All right, I'm skipping this song. Sorry. There we go. That's more of the vibes. Let's write this, and then let's say add parse result failures where we're currently using non-null operators in the encode function. Yes. Is it going? I don't think that worked. Write the change again. Insert into index.ts. Oh my God, for Christ's sake. Is this really what we want here? I don't think we need that one, but we do want this one where we get the label. All right, we'll just write our own. If label is undefined, we'll say return new parse result dot fail, and we'll say new parse result dot type AST header and then we'll say qname label was undefined at offset I guess it's more, this is an index, huh? And we'll delete word there. Great. Is that the only non-knowledge operator? Great. Cool. All right, I'm gonna have O3 review this entire encoder and decoder and see where we get. So let's bump over here. Please code review this encoding and decoding for a DNS header packet or question packet. So this is a focus red pen pass. Upper bound is 259, but the wire format allows 255. Label bytes plus 1 equals 260. I don't think that's... Is that true? We have the descriptor. Label bytes, 255 label bytes. That's one root. $250. I guess that is right. Hold on, let's open this spec because I feel like I got that 259 number out of the spec. Oh, easy boats.
Do you know if they ate?
What?
Do you know if they ate?
I don't know. I kind of doubt my mom said that, but that's probably a no.
Yeah.
He's hungry.
Are you hungry? Do you want puppy chow? Do you want to eat breakfast? Oh, no.
Easy.
Yeah, I don't think they ate.
Yeah.
Let's go.
All right, where is... You better go get your puppy chow on. The question... So we're at section 4.4.2, right? Yeah, right here. 4.1.2, question section format. Domain name represents a sequence of bytes where each label... And then we have the sizes. 255. I guess I just missed the null terminator. We did account for that in the parsing, right? Oh, we do. We hit the, when we hit the null terminating, let me add a comment here. We've null terminating byte. Okay. Yeah, so this should be 260. I don't think you want the kind of food they eat. I'm gonna be honest, Anders. Alright, let's go back over here. So we fixed that. RFC-1035 caps each label at 63 bytes, but the code never enforces it. Ooh. Yeah. So let's get the label. Where's the label length? So in here we can say if label length. Actually, we can do this earlier. We can fail earlier. We can say if label length is greater than 63, we'll return a parse result failure. And we'll do new parse result dot type. And this is going to have our AST, the header, and then we'll get I'm gonna go close this door again. Mainly V0 credits. Lol. You guys know how Builder AI got busted for it being just basically a bunch of Indian devs behind the scenes? That's Anders for V0. QName label was must be QName label must be 63 bytes or less received label length. Okay. Name compression bytes. Whoa. Did I actually omit flags? I did skip the endian flag. I wonder if it talks about compressed Q names in the spec. Am I missing that? That's clever. That's really clever. In RFC-1035, can domain names be compressed in the section, in the QName section of the question? Or will they always be length, label, length, label. Okay, so they're not compressed. All right, so compression doesn't happen in the... Dude, compression's going to be wild to implement. That's so smart. That's so smart. I don't know if you guys are following what's happening here. So this data structure here. So this data structure contains f.isi.arpa, foo.f.isi.arpa, and arpa. So at this byte right here, it's saying that the length of the label is going to be 1 byte. So we get F, right? Then we move on and we see that the length of the next label is 3. So this F is this F right here. Then we get 3, and that's going to say, that's saying that's the length of this. So I, S, I, and then we hit 4. That's the next length for ARPA. We get A, R, P, A. Here's a null terminating bit. So that moves us on to the next domain name. We see it's a length of 3. We go foo, F-O-O, right? And then it uses, I haven't figured out how this works completely yet, but this indicates a pointer to byte at offset 20. So that takes us back over here. So this must be the number of bytes to jump, right? So this, I guess a 1 indicates a pointer. This must be the length to move forward. And we start at byte 20. So we go back to byte 20. We must skip that, go here. We see 3. So then it's foo.isa, or new foo.f. So that is a subdomain. So I did read that right. So that just moves us back here. And then we reread through this, right? And that reuses the data that was defined beforehand. And it does it again. That's so, dude, that is so smart. And 26 points here, which is the root apex domain, ARPA. That's so clever. How long is a field? Labels can be up to 63 bytes. So this, so this is a name is basically a combination of a length byte, which says the length byte, which is like this one right here. This says the preceding label will be this many bytes. So for this case, it is 1 byte, right? So it's just 1 byte. F is 1 byte. Then we hit this length, and it says the next label is going to be 3 bytes. 1, 2, 3. Yeah, they're pointers, exactly. I don't know how to read the 1, 1 yet. That must just indicate that it's a pointer, right? So it's saying it's a pointer back to byte 26. 26 is here, and it's going to be 4, right? We get a length of 4 ARPA, and there's the apex. I don't think the ones have any semantic meaning other than an identifier for the next thing is a pointer. This is so clever. Yeah, I think this is just it's 2 bits. On line 20, 1 and F have 8 bits. So this is a byte, right? Like this is a full byte. These rectangles are full bytes. This is just the ASCII value in the byte. And this is saying the preceding name is going to be 1 byte in total. So you read forward, you read 1 byte, and you know it's F. And then you move forward another byte, and you see, okay, I have 3. The next name is going to be 3 bytes. You read forward 3, 1 byte, 2 byte, 3 byte. You get ISI. Then you hit the next length one, and this says the next name is going to be 4 bytes. 1, 2, 3, 4. We hit a null terminator. That's the end of that name, or that's the end of the domain name. We then hit 40 here, right? This is saying, hey, the next name is going to be 3 bytes. FOO. And then rather than hitting a null terminating thing, we hit this 1. This 1, 1 is like, okay, the next section is going to be a pointer to somewhere that we've already processed. And it says, hey, go look at offset 20. Boom, we jump back to here, we read that, right? And we read back through this until we hit here again. So the full line, yeah, a full line is 16 bits. Yeah. Every line is 16 bits or 2 bytes. So if a line starts with 1, 1, it's a pointer to jump. That's so smart. That's so cool. I'm excited to write that. That's going to be fun to work on. We're going to. We'll probably get to that tomorrow if I had to guess. We don't need to worry about compression. NDN, we took care of that. To memory and performance. Per label data view. Leaks unrelated bytes if the label isn't the whole underlying buffer. Replace with simple byte copy. Oh yeah, I do have to do that. In our data views. For there. Label.buffer. I think we could fix this by doing It's true. Oh, that's so much smarter. Wait. Show me this code snippet used in this. All right, so uint array does a bulk mem copy, so there's no per byte loop and no per label object allocation. If you prefer to manual copy, you can just iterate. but if you're aiming for 0 per label allocations, yeah, we should do that. I do like the idea of naming those. That does make things clearer. So up here, in encode, we'll say const max label length and then we'll do const terminator and q fields length equals 5. And we'll take that comment and we'll put that above. We can actually make that a JS doc comment, get a little bit of nice hover docs on that. Check this out now, chat. You hover that, boom, beautiful. And we'll set that to terminator length fields, yeah. All right, so then we're saying that's the same. That's the same. I have open code installed. I just haven't taken the time. I hate I don't like screaming snake case. Is that an unpopular opinion? I don't know. I've just always hated doing constants as all caps stuff. I mean, fine. Fine, chat. It's fine. Fine. In fact, we can probably... In fact, do we have a... We might have a label up here we can just parse. Max items 63. Label. So we can use label to parse that. So we can say const decode label is going to equal schema dot decode, and then we'll pass in label. And this is going to take, yeah, we can actually use that. And then we don't even have to worry about that. Yeah, that's fine. I was gonna say we could use that other decoder, but this isn't an effect. Man, that guy should go. I mean, we could. I like the composition aspect of that. But we do pay a perf hit. I mean, we could do a decode label sync and not pay the perf hit and do a try catch. Okay, we can do that actually. We can do, this would be const underscore equals parse result dot, why don't I have, oh, hold on. 63. Parse result. Parse result dot try. Do we have a gen? No. Does this take a lazy? And this would be decode label sync. And that would get this. This is annoying that I can't. I just want to use a schema. I really want to say schema dot like const underscore equals schema dot uint or 8 array, and I want to give it a length. Oh, is that for a string only? It's a string filter. Min items. Bro. I think we can actually make this work. if we lie to the type system. I think I can actually do this. I need to set up a keybind here for 2/ queries. Oh, I do have it. TI. Nice. I didn't know I had that. All right, so I already did that. That's nice. So I should be able to do TI, TS. All right, and we do type of schema dot uint8 array from self dot type array dot buffer like, and the E should be the same thing, right? Encoded. I think this should work. Let's test this in another file. Let's do uint test.ts, go in here and import schema, and we'll say const label is going to equal schema dot uint8 array from self dot pipe, and this is going to have schema dot max items 63, and we'll say at ts expect error. I think this should actually work. Const decode sync is equal schema dot decode sync label, and then we'll have our uint8 array, and it'll be new uint8 array, and we'll just say it's gonna have like 1, 2, and then we'll say console.log uint8 array, and if we run this, run uint This is a quick trick for filling an array, chat. We should get an error here. Yeah. I think that will work. I want to make sure I can get my description. That's fine. All right, we'll do that. I like that. I'm rust pilled, so I like it. I'll take our question. What's your, let me pull up this link. All right, let's see here. I wrote about Go. Link in reply. I'm increasingly struggling to see a good use case for the language. I've used Go professionally for about 5 years now. I probably won't be using it or recommending it in the future. Before the programming language theory folk get too excited, no, it's not because there's no monads or that the type system is stuck in the 70s. Sorry. All right, let's read this quick. This is interesting. And it's short. Why I liked Go. The biggest advantage of Go is actually why people don't like it. Its low abstraction ceiling. In a team setting with varying skill levels, this means that you get much more homogeneous code. I agree with this. I think this is a great point. Yes, there's no elegance and there's a ton of boilerplate, but boilerplate can be generated by LLMs. Agree with all this. Homogeneous code is easy to understand code. Agree with that. There's less bike shedding. Agree with that. If you want to get 20 junior to mid developers of varying skill levels to produce shareholder value, then Go is a great choice. Agree. If you have more complicated languages, you definitely need someone in charge with strict standards. Agree. And a shared idea of taste. Also agree. Otherwise, you end up with a million different idiosyncrasies. Also agree. Effect helps with all this, though. Performance is also good enough. It's not the fastest language ever, but it's very easy to write code that does a good job performance-wise. Also agree. What Go is bad at? The second you leave the very narrow window of backend services, you start seeing holes in the usefulness of Go. It does compile to a native binary, but there's a lot of glaring holes where you probably want to use a different language anyway. WASM. Okay, Go currently supports WASM but ships the whole runtime, including the garbage collector. A hello world binary is huge and bloated. This essentially makes it a non-starter. Unfortunately, this also rules out the excellent Cloudflare worker ecosystem. Go's issues with WASM GC and is unlikely to be fixed anytime soon. At time of writing, the issue has been open for 2 years. TinyGo does a better job at this, but has fundamental language limitations like no reflection that make it difficult to use for anything non-trivial. I feel like this goes against his first point on like why it's good. Like, don't use fancy features like reflection. And like, how many people are truly using WASM? Web UI library, I don't think that's a very strong argument. Just use JavaScript for the web. As much as I would rather write OCaml for the web, but OCaml compiles really, really well to JavaScript and has React bindings. Same with Gleam. You could use Gleam too. I mean, I guess my argument here would be the change you want to see. I'm currently all in on TypeScript, a sparkling of Rust for performance for critical sections or places where WASM makes sense. For example, I'm using Rust compiled to WASM for its excellent cryptography libraries. This seems to be the best of both worlds, the performance of Rust and the ease of using TypeScript. TypeScript's ecosystem is getting really good. Tooling for TypeScript has gotten a lot better. Both Bun and Deno have standard libraries and tooling that makes it far less awful to work with, except for the DNS libraries. Libraries have gotten more mature and stable. The days of crappy NPM packages are over. Things like Effect, let's go, Effect mentioned. Bring FB to the ecosystem, archetype, yep. I don't really agree with that. This is true. Although I think we're getting shared memory struct soon. There's like an ES6 proposal for that. I don't think anyone reading this would be convinced by these arguments one way or the other. I think they're pretty weak. I don't know. If you're using effect, like if the argument is to use effect instead of Go for backend services, I'm mixed there. Like there are things where you should use Go instead of effect in TypeScript, like just flat out. But I still think in large engineering shops, Go is a good choice, even though I don't like writing it. But not for the reasons he's called out. He has like some very specific reasons. I agree. I like Go's error does not equal no. Yeah, agree. I don't know. I think like it's a decent reason for him. Like if he worked in a large engineering org, I don't think it's a very, especially oh my god, especially one that's already all in on Go. Like I don't think you should. I don't know. I don't think it's convincing. They're like fine arguments. I don't think it's an L, but all right. So that seems to have worked, right? We got that working. Nice. Okay, so we can use this to parse now. So let's yoink you and come over here, and label will become that. And we can get rid of this. Decode label sync. Bump that down. And we'll jump down here. Does this have a overload? No, it only, okay, we have to do a try and catch. Decode label sync. So we get the label here, right? But we don't have the label. Maybe that's not where we want to parse the label. I guess it doesn't really help. Is bulk set better than set uint? Oh, I guess it is. That is a better way of doing this. What the hell's going on back there? What we got next? Incubus. Let's jump down to here. I'll bump this over to there. There we go. That feels better. All right, so let's say const out equals new uint array from the buffer. That's smart. And then we'll get rid of this. And we'll say for const label of header.name. That gets rid of our one error that can happen, right? Data view dot set uint8. And that'll be right offset plus plus, and then label dot length. Yeah, that's actually very smart. What was I doing before? I don't think I need to do this set. Can't I do something like... If not, the riot must happen. You did miss the dogs, but I will go grab them before I raid somebody. Let me make sure, yeah, we can go a little bit longer today. I want to get this working. Does this share memory? Oh, good point. We didn't do... Oh, Verz, thank you. We have to do Winnie's eardrops.
Hello?
Are you in your car?
Yeah?
Where'd you go?
Bodhi and I are going to school.
Oh, we forgot to do Winnie's eardrops.
I didn't have time.
All right, I'll get my mom to help.
Okay.
Okay, bye.
Bye. Wait.
She said, wait, I hung up. Is she gonna call me back? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, she's not calling back. All right, I'm gonna go get Winnie. I'm gonna have my mom help me, and we'll. Mom. Mom, are you up there? Mom? Miss Winnie. Are they in on my desk? Aha, they're right here. Here. We're gonna do your eardrops and then we're gonna get a carrot.
So when I started doing stand-up in 1997, the only place that would allow me to go up on stage and do what I do were bars. Dive bars, rough bars. Martina and I, that's where we met many years ago, performing at this bar in Montebello, California. And we had a fight.
I got it.
Are you sure?
Yeah, don't worry about it. I got it. Yeah, no, I got it. Alright, chat. Winnie's favorite treat is a carrot. So we're gonna give her a carrot once she gets her ears cleaned. You wait. We gotta do your ears first. You know what this is? Yes. You gotta do your left ear. Come here. Sit. Come here. Come here. It's okay. Sit. Down. Down. Good girl. Sit. Down. Here, let me do it, Winnie. It's okay. Come here. Wait. 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 Here. There we go. Yeah, that feels good now, doesn't it? See, once we do it, it feels good. Wait, we'll get your carrot in a second. Yeah, it feels good. Yeah. Alright, here you go. You can have carrot. Sit. Pretty. Sit pretty. Good girl. Crunch, crunch. How's that, chat? Oh, dude, she's a crackhead for carrots. 12 out of 10. Thank you, thank you. Why would you need to call in the for loop if it's a view on the same memory and we're already updating the memory through the data view of the array buffer? You're absolutely right. Chalk whites. Oh. Oh, I do see. This does make sense now. That makes sense. Yeah, we can do that. That's fine. Okay. Yeah, there we go. I have a 5-pound Pomeranian that likes peas. How this happened, I have no idea. Kind of reminds me of Polyphia. All right, what was the other bound checks? Technically safe. You already guard. Yeah. ND and clarity. All right. Error semantics. Symmetry and fail fast. Wait, encode checks for undefined label but not 0. All right, so let's have it re-review this code. Re-review this code.
Functions describe the world.
All right, this doesn't remind me of Polyphia anymore. Decode never rejects labels greater than 63 bytes. All right, so we need to add the 63 byte label. This is the label, right? I wonder if we should set QName to being yeah, why don't we do that? Why did I totally skip parsing, adding the make QName something like that. And this would be 7. Although, Winnie, dude, why? Why? Why are you barking? Get out. There's nobody here. If Justine were here, be fine. We could also do... I'm so sorry. Scared the hell out of me too. We could do... I mean, we could pack it so it's like that. Yeah, I like that more. Yeah, we'll do it like that. Well, we don't even really need that because we have the length. Oh, that's why I did that in the first place, because we inherently have the length. We inherently have the length because it's the length of the array. Never mind. So we just need to make sure that value, if value dot length is greater than 63, we're going to return a parse result dot fail, and this will be new parse result dot type AST uint8 array, and then label. I can copy the same thing we had earlier. Okay. Don't have to worry about compression bytes, extra byte times. Packet with trailing garbage is silently accepted. We'll catch that later. Where do I do this? Get uint16. Yeah. False. 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 Okay. Typo received. All right. Hell yeah, we did it, chat. Tiny micro optimization. Instead of new, and you can allocate one uint or 8 out and then use data view only when you need 16 byte writes. Whatever. Instead of new uint8 array buffer and one uint8. What? Is that true? Is that what it's suggesting? Whatever. All right, so to test this then, we should be able to come down here to this mock DNS question, and we should be able to decode, say decoded, and then that'll be decoded, and then we should be able to have re-encoded, const encoded equals, we need to go here and make that one, yep, down here, and then we'll pass in decoded, and then we'll have encoded, and then we'll say equal, and this will be yason.stringify mock DNS question is equal to yason.stringify encoded. And now when we run this, hopefully if we've done everything right, we see that they're true. First try. First try. Let's freaking go. Question encoding and decoding. All right, we can encode and decode questions or headers and questions now. Let's tweet this. Let's do, I want to do something like nice chat. All right, let's figure out how I want to tweet this now. We definitely want the code sample. Do I want this part? I kind of like this DNS question. All right, let's do the code first. We'll take this and do that, and we'll dump it in here. Well, that's TypeScript, my friend. I kind of want kind of want to have those go up to the last line. I guess we can do 16, and that gets it. And we'll do the other theme. I've been really liking this 11 Labs theme. Oh, I like the padding. We could probably rename this to R and get it. Must have, we might be able to change it down to max. There we go. Min. There we go. Nice. All right, so we'll copy that one and we'll go to Twitter and we'll say progress, question, decoding and encoding is done. Progress on RFC-1035. DNS question decoding is done. And then we'll go grab the bottom part here. This. We can save some lines here by doing that. And we'll do this. And we can delete those lines. And we'll grab, oh, you son of a bitch. No, we can't. We want those. Do this. And we'll grab up to there. And then we'll make that a screenshot. And we'll delete that bottom line, copy image, throw that there, and then the last one will be the output, which we'll grab this. Yoink. And we'll jump over and put that in. And we'll just say this is Yasan. Throw that in the tweet. Boom. Chat if anyone wants to come give me some boosts here. Yeah, I'm not sure I like the default AI. I use Code Companion. RFC-1035 describes like the how like the validity of domain names and DNS resolution and maybe servers too. Pepper, I stream this time every Monday through Friday. All right, let's go raid somebody. Pirate, Capybara. They're doing game dev or Janet. All right, chat, go show Janet some love, and I'll be back on Monday. And we'll work on, I think the answer section is next, and we'll get to work on like the compression stuff we looked at earlier, which is going to be fun.